Hello everyone, I will be talking about the implementation of CycleGAN in Keras Tensorflow. CycleGAN is an unpaired approach of image-to-image translation on two different domains A and B. Our objective is to perform image-to-image translation on celebrity to cartoon and then again reconstructing the image back to celebrity using CycleGAN in Keras TensorFlow. Similarly, we'll also be performing image-to-image translation on cartoon to celebrity and then again reconstructing the image back to cartoon using CycleGAN in Keras TensorFlow. Here we will be inputting the libraries. In this part of code, we will be loading the dataset which contains images of celebrity and cartoon and then resizing each of the image into 64 by 64 size image and then saving a compressed numpy array of both the celebrity and cartoon images which we will be using here for plotting the celebrity and cartoon images. Here we'll be defining a discriminator model which uh, purpose is to classify the generated images from generator as real or fake. We will be defining several convolutional layers and finally it will be one because we need to predict it as real or fake with loss as mean square error and Adam as optimizer. Now we'll be using a generate resonate block as generator is an encoder decoder model which takes input from source domain and generates image of target domain. So for that encoding, which can be interpreted using number of ResNet layers, we will be defining the ResNet block with two convolutional layers and then concatenating the image and output with channel wise. Now we'll be defining a generator which as a purpose of generating samples, fake samples. We'll be defining a composite model which is used for updating the generator by uh, using carousel and cycle laws, which has inputs as generator model 1, discriminator model, generator model 2. We'll be keeping the generator model 1 as trainable equal to false because we are only updating the generator model 1 and not updating the discriminator model and generator model 2, so it has been kept false. We'll then have discriminated our image discriminated output in entity uh, element forward cycle generated image and backward cycle generated image as outputs with Adam as optimizer. Here we'll be loading and preparing the training images from the dataset with the help of file. Now we'll be generating a real sample from the dataset that is taking a sample of images from the whole dataset where X is the sample of images and Y is the uh, label for each of the image, that is 1 because it is a real image. Similarly, we'll be generating fake samples where the X is the uh, generated model predicted image and Y is the label for that image which is 0 as it is fake. Now, in this part of block, we'll be saving the generated model files. Here, we'll be generating the samples and saving the model for after few epochs and plotting the images after few epochs. We will be now training a CycleGAN model which takes 6 inputs: discriminated model A, discriminated model B, generated model A to B, generated model B to A, composite model A to B, and composite model B to A. First, we will be for epochs 100. First, we will be mm, selecting a batch of real image from each of the domain, then generating a batch of fake images for each of the domain, updating the fake images from discriminated pool. After that, we'll update the generator B to A with the help of adversarial and cycle laws by keeping the discriminator A fixed. Then now we'll keep the generator B to A fixed and update the discriminator A. Similarly, we will do it for generated B to A to B, and discriminator A. We'll now run that function for training the epochs. We'll now select the best model for um, celebrity to cartoon and cartoon to celebrity, as 180 training step was performing good for celebrity to cartoon and 300 training step model was performing good for cartoon to celebrity. We'll now select a sample of images from the dataset to test on. Here, we'll now test on celebrity images, where real image is a celebrity which generates a cartoon image and then again reconstruct the image back to celebrity. We can see in the output that the generated image of cartoon captures some of the attributes of cartoon. Similarly, we'll do it for cartoon to celebrity, where with the real image is cartoon, which generates the celebrity image and reconstruct the image back to cartoon image. Here also, it captures some of the attributes of celebrity image. Finally, a model which has a high discriminator loss and low generator loss is good. We can see here the generator loss is 9.63 for celebrity and 7.43 for cartoon, suggesting a good model based on all the other models that have been trained on. For more details about CycleGAN concept and code implementation, you can uh, see on the description section the Medium article link.